Good morning, students. Today I am starting with a new topic, power system security. Already we have finished the load frequency control and AGC part. So today I will discuss with you regarding the basics of power system security. As all of you can see on the screen, what is power system security? See, power system security is defined as the probability of the normalcy of the system operation. That is, what is the probability of the system to operate under normal condition among all the possibilities of the disturbances taken. So, contingencies are known as the disturbances. So that is the power system security definition. Now there are three operating states of power system. The three operating states are known as normal state, emergency state and restorative state. The normal state is also known as preventive state. Emergency state, as all of you know, indicates the condition which arises in a system due to some emergency, and restorative state is the state in which the system is able to restore back to its normal condition. So all of you please see this figure, what I have depicted. These are the operating states of power system. You have preventive, restorative and emergency state. Okay, so there are all means these states are interdependent on each other. So this figure is actually given by one scientist, that is engineer Guy Lyco, who first pointed out that a system is operating in the three conditions or three states, and these states which I have already discussed. Now let us go to the first state, that is the preventive state, which we also call it as the normal state. So as I told you in this chapter or in this lecture, I will discuss the fundamentals. So first is the preventive state. Preventive state is nothing but actually the normal state, which means that all the apparatus or all the components are running within the prescribed limits, within the normal limits. So whatever, I suppose if it is a 220 volt system, the voltage remains within 220, the frequency remains within 50 hertz. So all are within the prescribed limits, there are no deviations. All the system variables are under acceptable ranges. Then whatever be the condition, the system, suppose there is any disturbance also, in spite of the disturbance also, the system is able to overcome that contingency and is able to run into the normal condition. Means it is able to maintain its stability, it is able to maintain its normalcy. So that is the normal state, or you will say preventive state. Preventive state means the system is taking all the preventive measures so that it doesn't run into trouble. So here one of the major important point is looking from point of view of the operator. That is, the operator should foresee means should see beforehand itself whether there is some contingency. Contingency usually indicates some sort of disturbance or abnormality, and then the operator should take the preventive measures, control action, so that the system is not going out of control and the system integrity and power quality is maintained. So it is the duty of the operator to maintain the normal state also. Okay, some fault occurs, then suppose some corrective measures are taken, the fault is cleared and the system does not get affected and it is cleared before the system goes into unstable state. That is the normal state. Now emergency state. Emergency state is when some of the components operating limits are violated, means they go beyond the control. Suppose there is a short circuit, the current rises to a very high value, voltage falls to a very low value, frequency is okay, but voltage and currents are very out of control, so they go outside the acceptable ranges, so then that system comes into the emergency state. So what happens in emergency state? The main objective is that first objective in the emergency state is to relieve the system stress by appropriate actions. Is to relieve the stress by appropriate action. So here the economics is not the important part, because your main important part is to clear the fault, to relieve the stress and to bring back the system into a normal state, to clear that emergency. Now what is restorative state? Restorative state means suppose it is a state where the system can still be brought back to its normal condition. Okay, so some part has lost the normalcy, but still the system can be brought back to its normal state by some actions. So that is called the restorative state. That means you can restore back the normal operation. So these are the three important states which are the fundamentals of the power system security. Okay, now what I have to discuss, that is the mathematical analysis. So in the mathematical analysis there are three generic equations which are describing the power system operation. Among the three generic equations, one is the differential equation and two are algebraic equations. So under the algebraic equations, the two algebraic equations, one we call it as equality constraint and another we call it as inequality constraint. In the equality constraint is that set of algebraic equations which are denoting the balance between generation and load demand. So your generation should not exceed much the load. So okay, so it should be optimum generation. So that is defined by the equality constraint, and inequality constraint is ensuring that the system should remain within safe and acceptable limit in spite of some disturbances. Okay, so these are the fundamentals of the power system security. In the further lectures, I will continue the topics. Meanwhile, if you have any doubts, please post it in the WhatsApp discussion forum. Thank you, students.